Hey, good morning. Happy Monday. It's May 18th, guys. We're almost done. We are on week 8 now of our distance learning. It's been 2 months. Holy cow. Um, it's going quick and taking forever all at the same time. Hey, so today is pretty straightforward. We've been talking about acids and bases. We're going to keep going with that. Today I want to talk about measuring acidity, and that's done through a process or through a measuring tool called pH. Now, in the Chemistry Live, the last one we did, we took a bunch of household chemical items and we added to that an indicator solution. And for that, we did red cabbage juice, and it changed the color. And that color coincided with a pH. Okay, but what is pH? We've never really truly talked about pH. So I want to do that today. And there's actually ways you can calculate pH. So that's what we're going to do today. So in Google Classroom, there's the PowerPoints. If you want to go through it with me as we go through it, you can. There's also the note-taking guide, so you can take that. And again, as always, you can write it out on paper and then take a picture, or you can fill in the Google Doc, whatever is easiest for you. But I'm going to fly through. When you're done, click turn it in, and you're good to go. Okay. Now tomorrow we'll do some practice on this. We'll calculate some pHs. But today I just want to talk about what is it and show you how to do some calculations. Okay. All right. So here we go. Maybe. Huh. See if we can get it to work. All right. There it is. So the pH scale, it is a spectrum. Okay. It's a measurement. What is pH? pH, H stands for hydrogen ions. Remember, hydrogen ions, that is the H plus. The P stands for the power of, okay? The power of hydrogen ions. And so pH is a measurement of how concentrated those H plus or hydrogen ions are. The more H plus ions there are, the more acidic the substance is. Remember the definitions we talked about, acids and bases. One of those definitions is acids build up H pluses, okay? So the more H plus I have, the more acidic. And now remember the range, it goes from 0 to 14. Right in the middle is 7, and that's neutral. That's what pure water is, it's 7. Anything less than that, going down in pH, is acidic. Everything greater than that, going up from that, is basic. Now, alkaline is another way of saying basic. So you look here and you say, well, you said they were bases. Yep, they are. Another way of saying that is alkaline. Okay, so this isn't new information, but that's the pH scale. And again, we did a whole lab where you could look at different things. Well, we looked at lemon juice, we looked at vinegar, we looked at water, we looked at stomach acids, we looked at a number of these different things. Okay, but again, below 7 is acidic, above 7 is basic. And the big thing is, what does that tell you? It tells you the power of hydrogen. How many hydrogen ions are there? Now, before we get going too far into that, I just want to show you why water is a 7, okay? Now, if you look at water, y'all know this. Water is H2O. It has 2 H's, that's these white beads, and it has 1 O, okay? It's H2O. But if you take that and break it apart, if I were to take one of these H's and break it off and form an H plus, I would start to form an acid. Well, what's left of the water? If I take one H off and a plus with it, I'm left with an OH minus. Now, water has equal parts H plus and equal parts OH minus. If I take those two together, I get H2O. Well, remember one of the definitions. A buildup of H plus makes an acid. a buildup of OH minus makes a base. So if those two are equal, H plus OH, they cancel each other out and they're exactly neutral. Okay, so when water breaks up, when it dissociates, half of it becomes H plus, half of it becomes OH minus, but it doesn't affect the acidity or the basicity or alkalinity of that solution. Okay, so check this out. If you have an acid, what does that mean? That means you actually have more H pluses than you have OHs. Now, if you have a base, it's flipped. You have more OH minuses than you have H pluses. And again, things like water that are neutral, they're equal. So I'm going to show you in a little bit how we calculate pH, but there's another phrase called pOH, and that's less common, but it's a complement to pH. So look at this equation right here. pH plus pOH equals 14. So if pH is 7 and pOH is 7, it equals 14. Okay, well, what if H is, for example, like this one, what if H is greater? What if H is 8? Well, then we know pOH is 6. What if bases are greater? What if bases are 9? Well, then we know pH is 5, because when I add pH and add pOH, they're always going to equal 14. And we'll get to that later, but I want you to see, because water dissociates into H's and OH's, that's what starts this sway in one direction. If I get more H's, I get an acid. If I get more OH's, I get a base. And that's what this power of hydrogen, this pH or pOH, show you. Okay. Now, one other thing, when we go to calculate it, pHs are logarithmic. This scale where it goes 7 in the middle, then 6, then 5, then 4. We talked about as I move down the scale, I become more acidic. Well, how much more acidic? Each number from 6 to 5 is not just one more, it's one more number, but it's actually logarithmic. In other words, from 6 to 5, there's a 10-fold increase in H plus concentration. It's a multiple of 10. It's 10 times more stronger. Okay, so if I go from 6 to 5, 5 is 10 times more stronger. If I go 6 to 4, it's 100 times more stronger. If I go 6 to 3, it's 1,000 times more stronger. So it's a scale of 10. It's what we call a logarithmic scale. Okay? And so I gave these examples here. So when I go to calculate it, how do I do that? Well, we can use our calculator. Now, again, as always, you can use your phone. Now, I don't know about y'all, but I have a iPhone. It's not very new or fancy, but when I hold it like this, I have my traditional calculator, but when I turn it sideways, isn't that how it works? It never works when you need to. See, I think I have to have it off the locked mode. Okay, now let's try it. Okay, when I have it here and I turn it sideways, I get the scientific calculator. Okay, and one of those buttons when I'm looking over here is log, it's log. Okay, so to calculate that, pH is actually equal to the negative log of my concentration of hydrogen. Now you see these little bracket marks at the top? Come on. This bracket here means concentration. So if I have an H plus in that bracket, that just means what's the concentration of H plus. All right, so for example, if I just told you the pH of a 1 molar, 0.01 molar solution of hydrochloric acid, HCl. Say, what is the pH of that? Okay, you could take your calculator and you could say, okay, well, negative log times 0.01. If you hit equal on your fancy little calculator, it would say 2. Okay, now what that means, if it's a 0.01 molar, that talks to its strength, its concentration. But really what would happen is this HCl would break apart. It would break apart into H plus ions, and it would break apart into Cl minus ions. Now, do I have any OH? No. So it's not going to become basic. But I do have these H pluses, and it starts to build up, and I get a pH of 2. That's a pretty strong acid. Hydrochloric acid is a strong acid, but you can actually measure it using your calculator. We'll do some of that later. Okay. So here's a helpful tip. If molarity of acid, remember molarity is just concentration. If it's 0.001, that's really the same as 10 to the negative 3. Oops, okay. So 10 to the negative 3 is the same as a pH of 3. All right. So when you have a hydrogen ion concentration, you can just write that to 10 to the negative x. And then whatever x is, that becomes your pH. Okay. So Y3, well, you move it over, right, from where the decimal point is. You move it over 1, 2, 3. So here's another one. If the molarity of acid is 0.00001, you get 10 to the negative 5. Why? Because that gets moved over 1, 2, 3, 4, 5. Right? 5 spots, so pH would be 5. So if I were to do an example, what's the pH of a 0.01, right? Well, how many spots is that? 1, 2, so that's 10 to the negative 2. So that has a pH of 2. So that's just one way to, that's just a little helpful hint. But again, you can always use your calculator, and I'll show you later how to do that better. Okay? Well, how about this POH? What in the world is that? You can focus on the OH ions instead of the H plus, but here's the deal. You can't actually measure that in the lab. You can only calculate it. So that's why, you know, if you say, well, why is pH the one? Why don't they use POH? Well, you can, but it's just a calculation. It's not actually a measurement in the lab. Same thing though. To find the POH, I just would find the negative log. And again, remember, those brackets mean concentration. Negative log of the concentration of OH molecules. And the trick still works. So it's 10 to the negative x. That x is POH. Now remember, pH plus POH equals 14. So what's my example? So if I give you the pH, again, of 0.01 molar NaOH. So again, that means that half of these break down into OH minus, and half of them break down to Na pluses, right? This is an ionic compound. Notice that there is no H pluses. So this isn't going to be an acid. This is going to be a base. Okay. So if I have if I have 0.01 molar, right? Well, how many spots is that? 1, 2. So it's going to be 10 to the negative 2, which is equal to a POH of 2. Okay, now if I wanted to find the pH, remember this equation. I could just go 14 minus 2, because pH plus POH, equals 14, and I would have 12. Okay, all right. It's the same trick as before, right? If I give you the molarity and it's 10 to the negative 1, 2, 3, then the pOH is 3, right? And then to find the pH, I can just subtract it from 14. Same deal. What if the molarity of a base, now remember it's a base, which means it has OHs, not H pluses, right? The molarity of a base is 0.00001. Again, 1, 2, 3, 4, 5, 10 to the negative 5, pH pOH, equals 5. Remember that first equation. pH plus pOH equals 14. So if this one is 5, what plus 5 equals 14? 9. Okay, so let's see if we can do some. Okay, let's see if we can do some. If pH equals 4, so we know the pH, it equals 4. H plus 1 equals what? Well, all that means, what's the concentration of H plus ions? Because it's 4, I don't even need my calculator. All that means is I have 1 times 10 to the negative 4 H plus ions. That's it. Well, that was easy. What's the pOH? Remember that first equation. pH plus pOH equals 14. So if pH is 4, 4 plus what equals 14? 10. So pOH is 10. All right. Well, what's the concentration of OH? So what I'm trying to show you is I can solve for all these problems, all of these questions with only the pH. I can tell you what's the concentration of hydrogen ions. I can tell you what's the pOH. I can also tell you what's the concentration of OH ions. Remember how that works, right? If it's 10, if pOH is 10, that's the same as saying pOH equals 1 times 10 to the negative 10. So here's how many concentrations of ions I have of hydrogen. Here's the concentration of ions I have of hydrogen. Here's the pH, here's the pOH, and then if I were to say, is that an acid or a base? Well, what number is bigger? Now, I'm not looking at pH or pOH. Concentration number, which one's bigger of these two? Well, this is 0.0001. This one is 0.0000000001. This is a really small number. This is small. This is really small. This is a lot smaller. This is larger. So I have more H pluses than I have OH minuses. So this is an acid, pH of 4. Remember the scale. Anything less than 7 is an acid. Okay, let's try another one. If the concentration of OH or hydroxide ions equals 1 times 10 to the negative 3, what's the pOH? Remember the rule. pOH is 3. Done. Right away. Then what's pH? Remember the equation. pH plus pOH equals 14. So if this one is 3, what plus 3 equals 14? That's 11. So the pH is 11. So right now in your mind you go, ooh, pH of 11, that's way higher than 7. This must be a base. But what's the concentration of hydrogen ions? Well, remember, if pH is 11, that's the same as saying 1 times 10 to the negative 11. So look what we have. Here's the concentration of hydroxide ions, OH minus. Here's the POH. Here's the pH. Here's the concentration of hydrogen ions. You're figuring out 4 things. And if you have one of those things, you can figure out all of those. Let's do another one. Let's keep going. We're almost done here. You guys are doing great. Ooh, that's hot. All right. If the concentration of hydrogen ions is 1 times 10 to the negative 5, what's the pH? Remember, that's a saying is a pH of 5. What's the pH? POH, excuse me. 5 plus what equals 14? 5 plus 9. So POH is 9. What's the concentration OH? Well, that's the same as saying 1 times 10 to the negative 9. So is this an acid or is this a base? Well, pH is less than 5, so that's an acid. I have a higher concentration of hydrogen ions than I do hydroxide ions. More H pluses than I have OH minuses. All right, last one. Calculate pH for these two. 0.01 molar HCl, 0.01 molar NaOH. So remember what that means. I will get H plus ions and Cl minus ions. Here, I'll get Na plus ions and OH minus ions. So hopefully in your mind you say, okay, this one's going to be an acid, I know that. This one's going to be a base, I know that. But now I got to calculate the pH. Okay, so let's do it. Let me erase my boom. Okay. So I know it has 1, 2, 10 to the negative 2. So pH is 2. Done. Done. Well, how about NaOH? Okay. Well, same thing. 1, 2. Now, some people are going to say, well, there we go. pH is 2. But is there any H here? No. So we didn't solve for the pH. We solve for POH. So to figure out the pH, remember I need this, right? I need this one. pH plus POH equals 14. So if POH is 2, what plus 2 equals 14? That's 12. So that's below 7. That's an acid. This is above 7. That's a base. Now, guys, I know that's a lot. We'll do some more calculations of that, but I wanted to introduce you to concentration of H plus hydrogen ions, concentration of OH minus hydroxide ions. I wanted to introduce you to pH and POH. I wanted you to see that we can calculate these things. I want to remind you that everything lower than 7 is an acid, everything higher than 7 is the base. And I just wanted to show you how that all worked, the power of hydrogen, this pH. It's a big part of acids and bases, and now you know how to do it. Okay, guys, happy Monday. You got this. Fill out that sheet, click submit, and you're done. Reminder, we do have Chemistry Live tomorrow, Tuesday at 10 a.m. or Thursday at 1 p.m. Pick one, and we'll see you there. Okay, love you. Bye.